All right, so we are going to go to the next lesson, which is 7.2. And it says areas of other parallelograms. Well, what were the ones we did before we do the other ones?
We did quadrilaterals.
We did
Yeah.
rectangles, parallelograms.
Rectangle,
Parallelograms.
a rhombus. No, did we do a rhombus? Did we do a rhombus? Yeah. And a square. Didn't we? Isn't that what we did? I don't know. Something like that. So here's some other ones. What do you think another... we did triangle, didn't we? Didn't we do triangle, rectangle, and rhombus?
Yeah.
Something like that. Okay. So what are some of the other parallelograms that we've done? Trapezoid. Okay, actually it says other parallelograms, but then they put trapezoid in here. Oh, you know what? It shouldn't be other parallelograms. My bad. It should be other quadrilaterals. Quadrilaterals. Right, so they're not all parallelograms because a trapezoid, listen, a trapezoid is not a parallelogram, is it?
No,
So, so I don't want to say parallelograms, other quadrilaterals. Okay, enough of that. So let's do a trapezoid. For those who were here yesterday, I just gave you the formula, super easy and quick, and you're able to do a few from that worksheet. This time I am going to show you how we got that formula, okay? Because that's what math teachers like to do. Like to show you why things are what they are. I don't do it all the time because sometimes it's a little too difficult for you to understand. Sometimes it's too difficult for me to explain it. But on this one, it's pretty simple. So let's take a look. So what I'm going to do, we can just use white again. Here's trapezoid. Everybody got it? So we have exactly one pair of opposite sides parallel to each other. So this top one and this bottom would be the ones that were parallel. I didn't mark it, but just believe me, they are. All right, so what if I drew a diagonal from here to here? Let's try it again. Very good. We get two triangles, don't we? Oops. I don't know why it keeps jumping up there, but that's good enough. Now, are these triangles necessarily congruent?
No, not necessarily.
No, not on a trapezoid, okay? They're not necessarily congruent to each other. If you look at this, that kind of looks, I don't know, 90-ish. Look at that. That angle right there looks a lot bigger than that angle right there. Would you agree?
Yeah.
So right there, you can just say that they're not going to be congruent to each other. But we do have two triangles. But what I'm talking about, we're talking about area now. We're not even talking about things being congruent, are we? So we're just talking about things, the area of things. So let's do this. Let's do this in a different color. We know how to find the area of a triangle, don't we? What's the area of a triangle? Okay, base times height divided by 2, or you could say 1/2 times the base times the height. In this particular example, I'm going to use the 1/2. Is that all right? 1/2 times the base times the height, and I'll show you why in a minute. So let's do this. Let's find the height of just this triangle right here. In fact, the height of this triangle right here is going to be the exact same thing as the height of this triangle right here. So where would the height be? Well, from the top to the bottom, right? But not just from the top to the bottom. What is it? It's perpendicular. That's right. Yep, perpendicular to the base. Very good. So we're going to go from this point right here, perpendicular to the base. And so this pink one right here, I'll put a right angle there. That would be the height. But it would also be the height of this one here. This one looks like an obtuse triangle, doesn't it? So the height's not going to be, well, you could put it inside it. Well, no, yeah, I guess you could. You could go right here, I guess. But this height is going to be from here to here, all right? And if I extended this, see, I went from one point, see this, I don't know, this triangle on the right-hand side here, the top right. If I took this and extended it out, this would be the base of this triangle, and this would be the height. Or you could go from here, you could extend this out a little bit and take this up to here. Everybody see that? If I extended this side out a little bit and I went from here and I went perpendicular to this side, that would be the exact same thing as this pink one. Just not going to do them both. I'll just do one. So what are we going to call this one? This is the height. And it's the height of both of them. Okay, that's what I wanted you to see. Everybody see that? It's the height of both triangles. All right. Well, let's take a look at this triangle. By the way, they call this triangle 1. We'll call this A1. Why did I use A? Area. This is the area of triangle 1. This is the area of triangle 2. Okay? You with me on that? So what do we need to find the area of a triangle? We need the base and the height. Well, we already got the height. We know what the height is. So which one is the base here? If this is the height, it's perpendicular to the base. So this side right here would be the base, wouldn't it? Okay. Yeah, and let's call this let's call this B1. Okay? So this is the base because that's the base of triangle 1. Where is the base of triangle 2? It's at the bottom, this one right here. So this would be B2. Agreed? All right. So to find the area of the whole entire trapezoid, let's go back to white. It's easier to read. So watch. I'll just put trap. Is that all right? Okay. So the area of the trapezoid, it's going to be the area of triangle 1, what? Plus the area of the whole entire trapezoid would be the area of triangle 1 plus what? The area of triangle 2. Do you agree? All right. So let's write what the area of triangle 1 is. It would be what? 1/2. Which base? Because there's two bases and they're two different numbers. So which base? I'm trying to find the area of triangle 1. Okay, so here's triangle 1. I'm trying to find this area right here. So it's 1/2 the base. Which one is the base? B1. Okay, times the height. What's the height? It's just h. Now it doesn't have to be h1 because what's true about the height on both of these? They're both the same. So I don't need to make it h1 and h2. It's just h because it's the height it's the same thing for both of them. All right, so that's the area of triangle 1 plus what? The area of triangle 2. So it's 1/2 the base times the height. What's the base of triangle 2? B2. And then times the height because it's the same height. Now, you probably, if you wanted to, you could write this as the area of a trapezoid, but we can simplify this a little bit, all right? Do you remember factoring in Algebra 1? Yeah. Okay, factor out a greatest common factor. So what's in common with both of these things right here? 1/2, so we're going to factor out 1/2. What else is in common?
H.
The h. Is the B1 and B2 in common with both of them? No, because they're two different things. They're two completely different numbers, so they're not in common, but the h is in common. So now I factor it out. Do you remember this from Algebra 1? Yeah, you did factoring, didn't you? I'm sure you did. You did basic factoring anyway. So what's left over? If I divide out 1/2 and an h, what am I left with?
B.
A B1. It's not just a B, it's a B1. And then you put the plus. If I factor out a 1/2 and an h from this, what am I left with? B2. And check this out. For those who were here yesterday, does this look familiar? So the area of a trapezoid is this. All right, and that's how you find the area of a trapezoid. It's very, very similar to the area of a triangle. They both start with T, right? It's 1/2 the base times the height, but a trapezoid doesn't just have one base. How many bases does it have? It's got two bases. It's got two different bases. So what do you do with those two bases? Just add them up. Okay, so really, it's very, very similar to the area of a triangle. 1/2 times the base times the height, except you're finding the entire base of the trapezoid, which is the two bases added up. All right, pretty simple, isn't it? Yeah. So let's do a quick example here. And for those who did the worksheet yesterday, this should look very familiar to you.
When you do the area, do you have to 1/2 times the height?
Doesn't make any difference. So technically, look, I put 1/2 the height. To tell you the truth, now that you said that, it probably will look a little bit better if you do this. B1, it's the same exact thing. It really is. Everybody see that? Okay, so this is probably what they write in the book, I would guess. Yep. Yep, that's probably what they write in the book right there. Okay, so this is probably a little bit better because there's 1/2, there's the base, there's the height. But really, is it any different than this? No, it doesn't matter what order you multiply things. Okay? All right, so let's do this. Right there. And so here's a trapezoid. And they give you some stuff. They give you that this is 4.25. And they give it to you in inches. They put that two little, yes. Okay. So they put these little two things right here. I'm not going to put those. What is that? What are the two little things? Almost looks, it's inches, but I'm just going to write inches. Is that all right?
Yeah.
Again, you got to be very careful about the units. Very careful about the units. Because they're gonna do something in a bit that it's going to trick you up maybe a little bit. For those who were here yesterday, we talked about that. And then they tell you that this is 6 inches. Oops.
Yep.
Okay. All right, so here we go. And what do you think they're going to ask you to find?
The area.
Yeah, they're going to find you the area of the trapezoid. I'm not just going to put a T because it could mean what? Area of a triangle. Okay, so I'll put trap for trapezoid. All right, and what's the formula? It's 1/2 times the base, but you got 2 bases, so what do you do with those bases? You add them up, and then you multiply it by the height. Okay? So here you go. You just do the math. This is so straightforward. It's just super easy, okay? They give you both bases. They give you the height. It couldn't be any easier, right? So what do you do with those two things? You add them up. Doesn't matter which order you add them up in. Doesn't matter what order you add them up.
No, yes, sir.
No. Okay? And plug all that into your calculator, and you get 22.5. That's area. So it's 22.5 what?
Inches squared.
It's inches squared. Do not just put inches. Listen to me. For about the 5th time, I think, since I've been doing this chapter. Do not just put inches. Do not just put 22.5. You must, listen to me, you must have inches squared on this. If you don't, it's wrong. Everybody got it? So you got to think about it. All right? Make sure that you think about it every time. When you do your homework, make sure, now I don't grade your homework right or wrong. Okay, I just grade it on if you completed it. So I'm not looking on your homework if you put inches squared or inches or centimeters or whatever. But you need to do that every single time you do a homework problem so that you get in the habit of it. Don't think you're just going to remember when you get to the quiz or the test. Anthony.
So when you plug all that in, you add it first, then multiply by
Yeah,
6,
yeah.
then divide by
Right.
2 or times it by half.
Yeah, it doesn't really matter. But you do have to add these up first.
Yeah.
So that's what, 7.5, right?
Yeah.
And then it's 1/2. What I would do, I would go 1/2 times 6, which is 3, and it's 3 times 7.5. All right. To me, that would be easy. You can use your calculator. You can do it off to the side if you want to. However you want to do it. That's how I would do it. But you get 22.5 inches squared. Okay, enough of that. Let's move on. So we said we were doing other quadrilaterals. That's one of the other quadrilaterals, which is a trapezoid, which is one of the other weird quadrilaterals. You got it? What's a typo? Did I do something wrong?
No, on here.
On the worksheet?
Yeah, one base is yard.
Right, it's not a typo. We're going to talk about that in the next example, okay? All right, let's take a look. So we did a trapezoid. What do you think the next quadrilateral?
Kite.
Yeah, we're going to do a kite. All right.
You guess it's wrong with the test. Like getting the mitochondria.
All right, here we go. So I'm just gonna eyeball this. I'm not gonna get real perfect and flip it and all that kind of copy it and flip it. All right, so what do we have right here? We got a kite. Now, what we're gonna do with this is we're gonna draw the diagonals right there. And I'll tell you what, let's do this. Let's make this a different color just so I can refer to it. Okay? All right, so there you go. It's a kite. It's not perfect, but it's pretty close. And what we're going to do is we don't know what the formula for a kite is, do we? So guess what we're going to do? We're going to come up with it. Okay? We're going to come up with it. We're not going to make it up. Let's put some letters in here. This is P, Q, R, and S. And nothing in the middle. Okay? Yeah. Paper towels. We don't have tissues. Let's do this. What do we have? We have two what? Just like we did on the trapezoid.
2 sides. Equal angles. 90 degrees.
Two areas.
Just like on the areas of what?
A triangle.
Of a triangle. Okay? Would you agree?
Yes.
So let's take a look at this. Let's look at triangle. I'll tell you what, let's just write it right here. Let's do this in white instead of pink. All right, let's look at the top. We'll call it the top and the bottom one, okay? So let's look at triangle PQR. Everybody see it? I'm not going to shade it in or anything because it gets too messy. Right? Everybody see the top triangle?
Oh, yeah. Oh.
Serious? PQR. So let's find the area, but we got to put some stuff in here first. So what I'm going to do is I'm going to call this yellow one right there. I'll tell you what, let's write it in yellow just to keep it color coordinated, make it easy for us. We're going to call this D, but we're going to call it D1 because there's two diagonals. Do you see the two diagonals? You got the yellow one and you got the what?
Purple one.
Well, I called it pink. And you got the pink one. We'll call that D1 and D2. Everybody with me?
Yeah.
Okay, so D1, it doesn't just go from the middle. Where is D1? It's QS, isn't it? Right, QS, that whole thing is D1. Actually, let's switch it. Sorry about that. I got the ones and the twos mixed up. I just want to stay consistent with my notes. I could have done this and switched them up, no big deal, but I just wanted to be consistent. All right, so the D1 is the pink one and the D2 is the yellow one. So if I was to find the area of triangle PQR, everybody see that? The area of PQR. So what would the area of this triangle be? PQR. Well, it's 1/2 the base times the height. Agreed?
Yes.
Okay, for this top triangle. What is the base of this top triangle, PQR?
So D1.
D1, right. Let's use the letters we put here, D1. Would you agree? Now, here's the tricky part. What is the height of triangle PQR?
1/2 D2.
That's it. Exactly right. See, D2 is this whole thing, isn't it? What's the height of it? It's just from Q down to this point right here. So what is that? It's half of D2. Would you agree? So I'll just put it right here. Half of D2. So that's the area, okay, of triangle PQR.
Why is it half D1?
Because it's the area of a triangle. This half is because the area of a triangle is 1/2 the base times the height. Okay? So it's 1/2 the base. This right here is the full base. Okay? So we're finding that whole thing right there. That's the base. That's the area of a triangle. That's how you find the area of a triangle. It's 1/2 the base times the height. Okay? No, it's a good question. I don't mind questioning. So look, the area of this top triangle. What's the area of a triangle? The area of a triangle is 1/2 the base times the height. Okay? So let's take a look at this. So why is this first 1/2 here? Because that's what the area of a triangle is. It's 1/2. Okay, what's the base of that top triangle? It's D1. That's why I put D1 right there. What's the height of this top triangle? It's half of D2. So that's why I put half of D2. Okay? Let's simplify this as much as we can, and then we'll go to the other triangle. So what would that be? What's 1/2 times 1/2? 1/4. And then what? D1, D2. So far, that's the area of that top triangle, triangle PQR. You with me? Let's do the same thing for the bottom triangle. Let's call this PSR. Okay, so let's find the area of the bottom triangle. Well, it's 1/2 the base times the height. What's the base of this bottom triangle? D1. What's the height of that bottom triangle? It's half of D2. All right, so that looks very similar, if not exactly like that. Would you agree? So what is it? 1/4, what? D1, D2. But what are we trying to find? Not just the area of a triangle. We know how to find the area of a triangle. We want to find the area of the what?
Kite.
Of the kite. We want to find the area of the kite. I'll put area.
So you took the two of them.
And do what?
Split them in half.
Split them in half. Yeah, add them up. Because look, we found the area of the top one. We found the area of the bottom one. So how do you find the area of the whole entire thing? Just add them up, okay? You don't divide them by 2. You just add them up, okay? You just add them up. So the area of the kite, let's write it down like this. The area of the kite, we'll call it AK, is that right? Is equal to the area. You guys aren't paying attention. You're not going to listen. You guys are so worried about making jokes all the time. It's PQR. I guess you are freshmen, so I guess I should expect you to act like freshmen. Let's take a look. So the area of the kite is equal to the area of the top triangle, which is PQR, plus the area of the bottom triangle, which is PSR. All right, so let's do that. You ready? So what's the area of PQR? It's this one right here. It's 1/4, what? D1, D2. Agree? Plus, what? 1/4, D1, D2. Now, what do I have to do? It's like this. It's like 1/4 x plus 1/4 x. What would I do there?
2/4 x.
Okay, what's 2/4? Okay, so watch. Everybody watching? Here we go. Now we have the area of the kite. We are ready now. We'll put A with a little k. It's 1/2. Because what's 1/4 plus 1/4? 1/4 plus 1/4. It's not 2/8. You don't add the bottom when you add fractions. It's the denominator stays the same. It's a common denominator. All right. So the denominator stays the same. You add the numerator. So it's 2/4. 2/4 is 1/2. And then what's my like term? It's D1, D2. Don't you wish you would have listened better in your Algebra 1 class?
No.
There it is. So that right there is the area of a kite. There's no D4.
Sam, you don't
Just write it down. Just write it down. Think about it. Let's do an example.
There's two D1s.
I see what you're saying. So it should be like 2D.
Look, listen to me. Listen to me. This is algebra. Shh. If you stop talking, maybe I could explain it. This is algebra, okay? This is 1/4 of a term plus 1/4 of the same exact term. For instance, what if I had 1/4 x plus 1/4 x?
1/2.
It'd be, if I got 1/4 of an x and I got another quarter of an x, forget the x. If I got quarter of a pizza and I got another quarter of a pizza, then I have what? Half of a pizza, okay? So watch. If I have a quarter of an x plus another quarter of an x, what do I have? I got half of an x. So if I have a quarter of D1, D2 plus a quarter of D1, D2, I have now a half of D1, D2. Agreed? It's just like terms. You're just adding like terms. So you're not adding the D1 and the D1 to get a D2. That makes no sense at all because
shouldn't it be 2 D1?
because you're adding a fourth and a fourth. A fourth and a fourth is a half. And then you just keep the term, okay? You don't add D1 and D1. You don't add D2 and D2, okay? You add the coefficients, the number out in front, just like this. For instance, if I said, what's 2x plus 3x?
5x.
So you add the coefficients, which is the number out in front, and then you just keep the term exactly the same as it was. So look.
You do x plus x, then you get 2x, right?
You don't, but that's pre-algebra. Come on. I'm showing you right now. Okay.
Yeah.
I didn't think I was going to have to teach this stuff. So watch. If I have 2 apples plus 3 apples, what do I have? I got 4. How about 5 apples? I don't add the A plus the A and get a 2A and then add it to the 5. Okay? 2 apples plus 3 apples is 5 apples. Didn't think I'd be doing this with a 9th grade honors class. Okay, let's.
Oh!
All right, here we go. Now let's watch very carefully. Somebody asked a question.
Because wouldn't D2 and D1 are two separate. Got you.
They're not too.
D1 rose.
Just say that. 1/4 with 1/4 is 2 E's.
Huh?
What's the grade?
All right, here we go. Everybody, look here. They tell you that this little bit right here. I don't know why everybody's talking because I'm showing you an example, and you're going to want to know how to do these. Now, this is 115. Now, look, this looks kind of weird because, look, this is 13. They say this is 115, but it's not 115 centimeters. If you look in the book, it's 115 millimeters, okay? Now, if this is a kite, what's going to be true about this little part right here, if it's a kite? Right, because remember, one of those is being bisected. Just one of them is being bisected. So if that's 115 millimeters, then guess what? That's 115 millimeters. Okay? Now, here's what the rule of thumb is. Okay? If they don't tell you how to write the units, I'll wait. If they don't tell you how your answer, what the units for your answer should be, the rule of thumb is go to the one that's the bigger one. Okay? Same thing on that worksheet. Okay, so they don't tell you, I don't think. I don't know, they might. I don't have my book open. I just have my notes open. Maybe I didn't write it. Has anybody got their book open to example 2? Does it say what to put the units in?
It's saying it's gonna end up.
I know, but did they say in the question, when they ask you the question, did they say put it in a certain unit?
Convert measures to light units.
Okay, so they don't say to put it in millimeters or
I mean,
centimeters.
the final answer is gonna end with millimeters.
This needs to stop. This is ridiculous. I mean, let me get away, okay, with a little cylinder. Okay? It needs to end. We're not in kindergarten making stupid little fart noises. Okay? It's ridiculous. Acting like little children. I'm trying to explain something to you that you're really going to need to know, and you're busy making people laugh with these stupid little childish noises. Knock it off. I've let you get away with a lot today. I've let it go. No more.
Guys, I have to edit that out. We have centimeters and we have millimeters. And you're going to laugh. Seriously? Get a little control of yourselves, please. You have centimeters and you got millimeters. So the rule of thumb would be to whatever the largest unit is, let's make it that unit. Okay? So what is the largest unit? Is it millimeters or centimeters? Centimeters. So we're going to change this to centimeters. Okay? That's the rule of thumb, if they don't tell you. But you got to look at the problem. They could tell you specifically, write your answer in millimeters, write your answer in centimeters. Okay? But they don't on this one, so we'll write it in centimeters. Because I think that's what they do in the book anyway. So what are we going to have to do before we do anything else? I'm going to have to change the millimeters to centimeters. So how in the world do I change millimeters to centimeters? That's it. Just move your decimal. Just move your decimal to the left. Everybody watch. Okay? Because 11.5 centimeters is the same as 115 millimeters. Okay? I could go through and show you another way to do this. I'm not going to. That should have been taught back in middle school or Algebra 1. Okay? So it's 11.5 centimeters. So we're not going to use 115. We're going to use 11.5. Everybody got it? So, do we know enough? What is the area of a kite?
1/2 and D1.
Right. D1, what? D2. Okay? Do I know D1? It doesn't matter which one's D1 or D2. But let's do this. We'll say this one's D1. So what is the D1? There's the 1/2. D1 is this whole thing, right? So you add them up. So that's 43. Everybody see where we got that? Okay, and then D2, which is from here to here. How do we figure out that? Add those up. But what are we adding? We're not adding 115. I guess you could and then change that to centimeters. But what are we going to do? Yeah, just add this to itself. So that would be 23. Okay, now, this is in, don't leave. You made me stop, I'm going to make you stop. So that's in centimeters, that's in centimeters. So what is the answer? It actually, let's just do it. It's 494 is what it is. 494.5. But you can do that in your calculator. But the important thing right here is to do what? It's not just centimeters, it's area, so it's centimeters squared. Okay? And there you go. So we have to do rhombus. I'll tell you right now, the area of a rhombus is exactly the same thing as the area of a kite. Okay? So the area of a rhombus is the exact same thing. All right? I don't think we have to go through that. So here's your homework.
So for the people that weren't here, we have to do this for homework.
Yep. Yeah, if you're absent, you got to double up because you were absent. So it's pages 308, 309, and it's 1 to 14. Now, there is one with coordinates on there, like X and Y, right? Ordered pairs. I think you should be able to figure that out. If not, we'll talk more about that tomorrow. But I want you to get 1 through 14, as much of that done as possible for tomorrow.